all these places where we see tangent, let's go ahead and clean that up and punch that into our calculator because that's just a number. So tangent of 60, we can plug into our calculator and it turns out to be 1.732. If we times that by 195, this nasty looking thing simplifies down to just a number, 337.7. We can simplify that a little bit. 60 tangent by turning it into 1.73 x1. And we can simplify that a little bit. By turning it into, so tangent of 45 turns out to be 1. So that just becomes x1. So now we're getting really close. Now we just want to get the x's on the same side. So we add this one over. We get 337.7 is equal to 2.73 x1. So then we divide both sides by 2.73. And we get 123.6. Let's just call it 0.7.
Why is it 2 instead of 1? Root 173. Why did it change from 1.73 to 2?
Because we have one x.
Yeah, because there's a 1 here. So when you add 1x1 plus 1.73 x1, you get 2.73 x1. Cool. So that was a lot of work, and it's not our answer yet, but that just gave us a really valuable piece of information. Now we know this distance is 123.7 meters, which means we also know this distance is just 195 minus that. So 71.3 meters. So now that we have a length, we can solve for this length and this length.
Cool. Okay.
And then that still won't be the answer, but because we eventually want a speed, right? That's what it's asking for, the speed of the second car. But it's getting us really, really close.
Okay.
So that was the toughest part, was making this substitution here and getting through that trig to get these values. Now it's just simple stuff, but a couple steps of simple stuff. So how do we find this hypotenuse magnitude if we know 45 degrees right here and we know that this is 123.7 meters right there?
Cosine. Right?
Good. So cosine tells us that adjacent over hypotenuse equals cosine of our angle. So we can use that to our favor by saying cosine of 45 degrees equals 123.7 over our unknown hypotenuse. So with some rearrangement, we get hypotenuse equals 123.7 divided by cosine of 45 degrees. Plug that into our calculator. One, 123.7 divide cosine 45. So 174.9 meters. So 174.9 meters there. Let's do the same thing over here. It will be the exact same process. Cosine of 60 degrees equals our adjacent 71.3 over our hypotenuse, which we don't know. 6 meters. Okay, so now we want to figure out how much time it took for this car to drive 174.9 meters to get to here. So in order to do that, we're going to either have to convert this into miles, or we're going to have to convert this into meters. I'd say it's better practice to convert into meters because that's standard units. We don't use miles very often in physics. So let's go ahead and convert this into,
It's asking for miles per hour though.
so yeah, so we'll, at our very last step will be,
Oh, to convert it.
yeah, we'll get
Okay.
like meters per second for the speed over here, and then we'll just have to convert to miles per hour.
Okay.
So we know that 15.5 miles per hour. So in order to convert that, we can say 1 meter. I'm trying to think of how precise we want to be here. Because we can say 1,600, or 1 mile is 1,600 meters, which is really close, but it's not exactly
Do you want me to look it
right.
up? Or do you know what it is? Let's see.
Well, yeah, I know. I mean, we can say 1 mile is exactly 5,280 feet. We can say 1 foot is exactly 12 inches. We can say 1 inch is exactly 2.54 centimeters. And 100 centimeters is exactly 1 meter. So that's the way to do it if we want to be absolutely precise. Or we could have said 1 mile is 1,600 meters, but that's like rounding. And so with this program, since it's picky, it's probably better to go the precise way. 15.5. Oh, but that was only converting miles into meters. Now we want to convert hours into seconds, so we'd say 1 hour is 3,600 seconds. So now we multiply everything on top, divide it by everything on bottom, and that'll be our answer. Any questions about that conversion while I plug it in?
No.
So I got 6.929 meters per second. Okay. So this board is getting really full. Oops, not 16. So 6.929 meters per second. And we know that we went 174.9 meters. And we want to figure out how many seconds that took. So the way that we can do that, if we take 174.9 meters, divide it by 6.929 meters per second. Meters cancel. Since seconds are in the denominator of the denominator, it goes on top, and we'll be left with seconds. 17, or 174.9, divide 6.929, 25.24 seconds. So now we know that in that same 25.24 seconds, this car needed to travel 142.6 meters. So to find its speed, we just do meters, divide seconds, and that's going to give us a number that has units of meters per second. That makes sense. And we get 5.65 meters per second. That's our answer, but just in the wrong form, so all we need to do now is just convert it into miles per hour. So now we're home free. Any questions while I set up our train track? That was a really, really involved question.
Yeah. I'm glad that we did it though.
Yeah, it's good practice. It covers a lot of areas. You get practice with trig, you get practice with converting, you get practice with algebra, so it's really good. So I got 12.638 miles per hour as the final answer. So now the very last thing you'd want to do is just ask yourself if that makes sense. And just by looking at the picture that they supplied for us, we can tell that this car traveled further than this car. So it makes sense that this car's speed would be a little bit less than this car's speed, but still in the same ballpark. So 12.638 is totally a reasonable answer. If it was something like 20 miles per hour, then we'd know like, oh, we made a mistake somewhere. Or if it was something like 4 or 5 miles per hour, same thing.
And then 100th would be like 2 out. Right?
Mhm.
Okay.
So yeah, 12.64. What'd you think, Jason? You follow that?
Oh, yeah.
No
I'm
problem,
really
right?
glad we did that one because that will be good to. I bet there's gonna be something like that on a test.
Yeah, it's
Maybe.
pretty involved.
You don't
I've
think
heard
so?
that wise tests are tricky,
I-
so it's totally possible. I mean, it's fair game.
Ours are online, so usually online tests are a little bit harder.
Because
so.
they know that you can cheat if you want to. Is
I
it-
don't know. I think it might be open book actually.
Oh, really?
But I
So
need,
then, yeah,
I need
open
to
book
probably
is
find
always
that
harder.
out.
Probably not open Google though, right?
Yeah.
Cool. So yeah, hopefully we didn't make any little calculation errors anywhere. Because it's easy to do when you do that many calculations, but I think that looks really good.
Cool.
Did you have a question, Jason? Like a homework question? We
Um,
can keep going through Emily's, that's totally fine.
there's another number 6 asked in the previous problem how much time passes before the car collides to the nearest tenth of a second. Oh,
Yeah, I was gonna say we already figured that out.
Yep.
okay, cool.
Because we got times for both of those.
Right.
Yeah, so just 25.24 seconds. It wanted the 10th though, so
Yeah.
25.2.
Okay, cool.
Well,
So yeah, there's a lot of work up front, but I mean, they could ask us anything at this point and we'd be able to tell them whatever. If they wanted to know this distance, we already found it. If they wanted to know that distance, we already did it.
Cool.
So it's nice when they have these big long questions that they end up asking a lot of follow-up questions because then you do a lot of work and then you can answer a lot of questions with it, but looks like they just asked 2.
bummer.
But
Yeah,
like
which is
most of my
fine.
stuff is always in meters per second, so I don't have to do a lot of that.
Yeah, it usually is, so it's weird that they reported it in miles per hour. We could have kept it in miles per hour, that probably would have been a
Miles per hour is a little bit more practical.